Hey YouTube. So today we are doing problem number 33 from the section on mesh currents. And in this problem we have a 60 volt independent voltage source connected in series with a 4 ohm resistor. This is 10, this is 1, 3, 2, and a 20 volt independent voltage source. And we have 3 branch currents that we're looking for. We're looking for this branch current going into this node called IA, this branch current going into this node called IC, and the branch current leaving that node, and that's called IB. So we're going to use the mesh method to find that, and then in part B, we're going to reverse the polarity of this so that it's minus plus instead of plus minus, so that it's a voltage towards ground. It would be a voltage rise towards ground instead of a voltage drop. Okay, so let's get started. Whenever I do the mesh method, I'm very methodical and OCD in my ways. I always take the mesh current to be in the clockwise direction. So I'm going to call this IA because that's going to be that mesh current. And then I'm going to call this one, instead of negative IC, or actually I could call it negative IC if I wanted to. But I'm not going to do that. I'm going to call it ID. And then I'm going to say IC is negative ID. And that is how I chose to do this problem. You could, of course, just do this and call this the positive direction if you wanted. Or, like I said, you could have called that mesh current, called it this one and called it negative IC. So that will work as well. But anyways, this is the way I chose to do it. So let's do mesh at IA. Remember that the mesh method leverages KVL, which is Kirchhoff's voltage law. It says the sum of all the voltage drops around a closed mesh must equal 0. And voltages, every term in your mesh equation should be a voltage, which means it should be current times resistance, or it has to be a voltage source. If you have positive current, you take the first sign that you run into on your independent voltage source, and that is going to be negative 60. So this, that's going to be important part B, because then you're going to reverse the polarity, and instead of being the first sign you're going to see, because it's going to be minus plus, it's going to be plus. So your equation will start out with plus 60. So in this case, we have a voltage drop with respect to ground, so the first sign that we see is a minus. Okay, so the voltage term here is going to be IR, right? So it's going to be IA times 4. So it's going to be plus 4 IA. This one here is the sum of 2 currents, IA and ID. So it's going to be 10, which is your resistance term. 10 times the net current, which is IA minus ID. And then this right here, which is going to be 1 ohm times IA. So plus 1 IA. That's all got to equal 0. Then we're going to take mesh at ID. So let's start here. We got 10 ohms of resistance. And the net current is going to be, with respect to this mesh, is ID minus IA. Plus this term right here, which is going to be 2ID. And then the first sign that you run into is the plus. So it's going to be plus 20. And then the next one, voltage drop, is going to be 3ID. Plus 3ID. And that's all got to equal 0. So now I'm going to build a matrix. My variables here, IA, ID, and constants. So let's gather all together the IA terms. I've got 4, and I've got plus 10, and then plus 1. And then for ID, I have a negative 10 term. And then over here, I've got 60. And from my mesh equation at ID, I have negative 10 IA, and then my ID terms are 10 plus 2 plus 3, and then that 20 will go on the other side as negative 20. Okay, so I'm going to double check. 4, 10, 1 minus 10, 60, 10 minus 10. Okay, so that matches, and just as a second double check, I'm going to go ahead and compute that. Okay, so you go to your matrix solver, you go new, 3, you have two equations and two unknowns. So 4 plus 10 plus 1, negative 10 and 60, negative 10 and 10 plus 2 plus 3, and negative 20. So I'm going to solve that. And what I come up with is, just to make sure, okay, so IA and ID. Okay, so what I came up with is IA is equal to 5.6 amps. ID is equal to 2.4 amps. Okay, IB, we know IB is going to be the difference. We know that IA minus ID equals IB, right? Let's get rid of this. Okay, so ID is going to be the difference between IA, because it's going in this direction. The positive current through the positive current is going to be IA, and the negative current is going to be ID. So we know that IA minus ID is going to be IB. So that tells me 5.6 minus 2.4 is equal to IB. So I got 2.6, 5.6 minus 2.4. So IB is going to be 3.2. So let's gather everything we have. IA is 5.6 amps. IB is 3.2 amps. And then IC is going to be negative ID, which means IC is negative 2.4 amps. And let me double check. Oopsies. Okay, so 5.6, 3.2, and negative 2.4. And that is the answer to part A. Now, part B. What will these currents be if I switch this around? Instead of like 60 is equal to plus minus, now I've got minus plus. So the only thing, now people learning for the first time about the mesh method, you need to actually redo these steps. Go back to the beginning of the video and rework part B from scratch. For me, I'm going to leave that to you, but everything is going to remain the same except for this in your matrix. That's the only thing that changes. So let's go back to my matrix. And so I'm going to go to my table, and I'm just going to make negative 60. And that tells me now, with that polarity change, IA is negative 8.8 amps. ID is negative, so ID is negative 7.2 amps. And IC is just negative ID, so that makes that positive 7.2 amps. And then IB is still IA minus ID. So that's going to be negative 8.8 minus negative 7.2. And that, you can do in your head, is going to be negative 1.6 amps. And that's my answer. Negative 8.8, 7.2. IA is negative 8.8. IC is positive 7.2, and IB is negative 1.6 amps. Okay, you guys, I hope that helped you. If you did receive help, please make sure to give help back by liking the Facebook link to this solution so that your friends in engineering can find this channel, and we can get more people involved and then more people participating, so it's more interactive. Thanks, guys.